Today we're going to talk about energy. Energy is the ability to do work. And then you ask, what is work? Well, work is the transfer of energy. So energy's definition has the word work in it, and work's definition has the word energy in it, so they are related terms. Energy cannot be created or destroyed, but it can be transferred or it can change forms. So just like mass, we can't create or destroy energy, but we can change where it is located, or I can change what kind of energy I have. Those kinds of energy, there are two general types. There's kinetic energy and potential energy. I have 6 main forms of energy, which are mechanical, thermal, chemical, electrical, electromagnetic, and nuclear, which we'll talk about later. When I have energy, I'm going to measure that in joules. That's my unit. So first up is kinetic energy. Kinetic energy is the energy of motion. I'm going to use that for moving objects. I can calculate kinetic energy with an equation. My equation is 1/2 of an object's mass times its velocity squared. When I do this equation, I need to square the velocity first to make the math easier for myself. So kinetic energy relies on mass and velocity. Here's a shortened version of that equation. I'm including the units for you. Mass we're going to measure in kilograms. Velocity we're going to measure in meters per second. Let's do an example. So I have a pitcher throws a 0.145 kilogram baseball at a velocity of 30 meters per second. How much kinetic energy does the ball have? Well, I'm going to use my equation, 1/2 mv squared. I'm going to identify the mass and the velocity of that ball. The mass is 0.145 kilograms. The velocity is 30 meters per second. I plug in my values. So kinetic energy is 0.5, which is 1/2, times the mass times the velocity, 30 meters per second, squared. I square this first to get 900. So I take 900 times my 0.145 times 0.5, and I get 65.25 joules because this is energy. Notice that since the velocity is squared, that is going to have the largest impact on my kinetic energy. Potential energy is stored energy due to position. I have 2 types, gravitational and elastic. Elastic potential energy is going to be due to either stretching or compressing something. So if I have like a spring, or if I have a bow, like a bow and arrow that I'm pulling back, as it stretches, I have more and more potential energy. If I take a spring that is normally about this size, and then I squish it together, compress it, that's going to have more elastic potential energy. The other type, gravitational, is going to have another equation with it. So I have mass times the acceleration due to gravity times the height that the object is at. I can shorten that up to be gravitational potential energy equals mgh. Mass is measured in kilograms. Acceleration due to gravity is always 9.8 meters per second squared, like we've seen. And height is going to be measured in meters. Let's do an example. A 60-kilogram person stands on the roof of a building that is 74.8 meters tall. How much potential energy does she have? Use the equation. Identify those 3 things that we need. We need the mass, 60 kilograms. The height, 74.8 meters. G, acceleration due to gravity, is always 9.8 when we're on Earth. So all I have to do for this one is multiply those 3 numbers together. 60 kilograms times 9.8 meters per second squared times 74.8 meters. And my potential energy for that person would be 4,398.24 joules because it's energy. So my potential and my kinetic energies can happen at the same time. Like if I have a ball flying through the air, it's moving, so that's kinetic, but it's also got potential energy because it has a certain amount of height to it. So I'm going to use the example of a roller coaster to show how they convert to one another. So when my roller coaster is going up the hill, I'm building potential energy, which I'm representing with the color blue. And when it goes down, I'm going to increase my kinetic energy because I'm going faster and faster and faster. When I go into the loop, I start to build my potential energy again because I'm increasing my height. And then when I come down, I'm increasing my kinetic energy because I'm increasing my velocity again. As I come up to the next hill, increase potential energy because I'm increasing height. And then increase my kinetic energy because I'm going faster again coming out of that hill. Here's another example. If I have a ball and I throw it into the air and then it comes back down, at the beginning I have a large amount of kinetic energy because I just gave it that push upward. And it has a low amount of potential because it's close to the ground. As it gets higher, I've increased my potential energy because I've increased my height. But I have less kinetic energy because, as we know, gravity is trying to pull it back down, so it's slowing down. At the top, I have the least amount of kinetic energy because it has slowed down completely, almost to a stop before it starts to come back down. And I have the most potential because it's the highest. As it comes back down, I start to lose my potential energy again because I'm losing my height. And I have more kinetic because it's starting to speed up again because of the acceleration due to gravity. At the bottom, the low amount of potential energy again, high amount of kinetic because it is moving faster. So that energy conversion between potential and kinetic can also happen with my other forms of energy. So I can convert mechanical energy into electrical energy, or I can convert electromagnetic energy into thermal energy. Well, what are those types? Let's go through that. So kinetic energy and potential energy of everyday objects. So like the ball going up in the air, or a roller coaster, or a person. Those are everyday objects, things that we can see and manipulate. Those are going to be that's my mechanical energy. It's not just for machines. When I look at the kinetic and potential energy of my atoms, that's thermal energy. So we know that our atoms are constantly moving to some degree. The more movement they have, the more thermal energy they have. We can feel that as heat. So if I rub my hands together, I'm increasing the amount of friction, and I have heat that is being produced from that. I'm increasing my thermal energy. So think about that for friction. Energy stored in the bonds of my chemical compounds is my chemical energy. So if I have CH4 right here, methane, whenever I break those bonds, energy gets released. So I find this in fuels, I find this in food. When I move my muscles, chemical reactions are happening in order for that to happen. Energy associated with electric charges is electrical energy, so that's going to be electricity, which we'll talk about later in the year. Energy that travels in waves is electromagnetic energy, another topic we'll cover later in the year. Some types of electromagnetic energy are light, X-rays, and radio waves. Energy stored in atomic nuclei, we just talked about recently. That's my nuclear energy. So when we talk about all that energy being released from fission, so splitting of my nuclei, or fusion, combining of my nuclei, that energy that's released is nuclear energy. So again, I can convert, nuclear into thermal, or I can convert chemical into mechanical, depending on what I am, what my goal is. For this last slide, I want you to think about a situation, an everyday type of situation. So imagine that you kick a soccer ball up into the air, it comes down, it rolls a few meters, and then it comes to a stop. Here are some questions I want you to write down the answers to in your notebook. Number 1, when the ball goes up in the air, what is happening to its potential energy? And then what is also happening to its kinetic energy? Number 2, when the ball is falling back to the ground, what is happening to its potential energy? What is happening to its kinetic energy? Number 3, what causes the ball to slow to a stop? So when it lands and it's rolling to a stop, what causes it to stop? Why doesn't it just keep going? And number 4, which form of energy is going to be increasing as it slows to a stop? So as it rolls to a stop, what kind of energy is increasing?